Hello, students. Today we're going to do Chapter 5, Lesson 5. You're going to need your book. So have your book out. If you don't have your book, have some paper out. Follow along as we go here. So our main thing here, we're going to be looking at functions. As we have shown, functions can be represented by a table, graph, equation, or words. And today we're going to compare two different forms of functions. So we might be comparing a table to an equation to words, etc., and so forth. Okay. All right, so we're starting here on page 309. This was your warm-up, so you should have completed this question here. It says Carlos's annual membership to the Science Museum can be represented by the function C equals 29.99, or essentially $29.99, where C represents the cost in dollars. The cost for Stephanie to pay her visit is shown in the table. So again, Carlos is the equation, C equals 29.99, and we see Stephanie is this table over there. Okay, so we are comparing these two costs. All right, so it says in order to compare them, let's make a table for Carlos. Well, we see Carlos has this annual membership. Annual means, of course, for 1 year. So he's paying the cost one time for once a year. So if he uses it for 1 month, it's going to cost him $29.99. 2 months is still $29.99, etc. All these months are 29. Okay. So the first question here is describe the rate of change for each function. So if we look at these two here, Carlos's rate of change is 0. It's not going up at all, right? There's no slope. It's this constant. We have this one single cost of $29.99, okay, and it does not go up from there. All right. So Carlos's rate does not change. If now we look at Stephanie, who has this here, we see the rate of change. Well, if we look at here, we see every month, every visit, it goes up $5, right? $5 for 1 to 2, again 5, again 5, right? So we are seeing that it's $5 per visit. Essentially, we could make a little equation for that. And we could say R 5 times V equals the cost, right? 5 per visit is going to be our cost. So 5 times 1 visit is $5, right? 5 times 2 visits is $10. Okay, that's essentially what this is here. All right. So the question is, if we are comparing these two, who pays more for 2 visits? We see Stephanie pays $10 for 2 visits. And Carlos, doesn't matter how many visits he does, it's going to be $29.99. So who pays more for 2 visits will be Carlos at almost $30. Stephanie only pays $10. Who pays more for 6 visits? Well, we can see if this is going up by 5. We know at 6 visits, should be 30, right? We see the same rate going up by 5, but we could also stick it into the equation, 5 times 6 being 30, okay? So who pays more for 6 visits? At 6 visits, we see that Stephanie pays more. So we could reason that if you are, and a lot of these memberships are the same way, if you're going to go more than 6 times, it would behoove you, it would be important, it would save you money if you got this annual membership that Carlos has got, okay? All right, so that was the warm-up there. So we're going to look at a couple other examples here as we go. All right, so going to our next page here. All right, great. So I won't go over this one too much in detail because it's already in detail in your book. But on 310, they compare a couple things here. We have a zebra's main predator is the lion. Lions can run at a speed of 53 feet per second over short distances. The graph to the right shows the speed of a zebra. Compare their speeds. So if we look at the graph, we notice it says lions can run 53 feet per second. Okay, so we have 53 per second. And our zebras, if we look at a graph, we can see at 1 second, it seems to have run 59 feet. At 2 seconds, it seems to be running at 118 feet. at 4 seconds, 236 feet. So we see our rate of change there is 59. So 59 per second, right? So whereas the lion is 53 feet per second. Okay. Right. And again, if we could have, you could have found that another way. If you didn't see that was exactly 59 adding up there, we could have just subtracted, right? Find our rate of change as they show here, 118 minus 59 all over 2 minus 1. Our rate of change is 59 over 1, or just 59 feet per second. Okay, so we see that a zebra can travel at a rate of 59 feet per second. So the speed of the zebra is greater than that of the lion. All right. All right. Great. Now let's look at another example here. So we're on page 310 here as well. So it says a certain car has a gas mileage of 22 miles per gallon. The gas mileage of a certain sports utility vehicle is represented by the function shown. So we have the sport SUV is right here, and in words they tell us that a different car is 22 miles per gallon. All right. So if we compare these two, we notice that what is the rate of change here? So we are comparing the mileage. Okay. Again, we could do it a couple different ways. We could just kind of see that difference going up. Remember, rate of change is the same thing as slope. So we can always take two numbers, such as that 76 there minus 38. And then if we put that over 4 minus 2, I'm going to draw that one, 4 minus 2. Okay. And if we subtract those out, we should get, if I'm doing that right, we should get 38 over 2. And then lastly, for 38 over 2, that simplifies to just 19 over 1. In other words, this one is using 19 gallons per mile driven, right? Or 1 gallon per 19 miles driven. That makes more sense. 1 gallon per 19 miles driven. Okay. So if this is 19 and this one is 22, we notice that this one shown on the graph on the right is more, doesn't get you quite as far, right? Only 19 miles on that 1 gallon versus 22 miles on the 1 gallon here. Okay. All right. So again, comparing our graph, finding that rate of change, comparing that to our word problem here of 22 miles per gallon. All right, let's look at a couple more. And you should write that in your book there as well. Make sure getting that down. Okay. So another example they give us here, we have looking at, I'll be quick on this one too, since it is already written in your book. We're looking at the speed traveled of two different trains. So we have a function m equals 140h, where m is the miles traveled in h hours, and that is for the Japanese high-speed train. So 140 this rate times that many hours will give you the number of miles, right? And we look at this chart here, and this is what it is in China. So Japan, right there, represented by that function, and then China, represented here by this table, right? So we could see the rate of change ends up being 217 per hour. So it keeps on going up by 217, 217, 217. Whereas this one, if we'd plug in hours for that, we'd realize every 1 hour it's 140, right? So if we are comparing the two, we could see that this is going 217 miles an hour, this is going 140 miles an hour, and of course the train there in China is going faster. And if you wanted to calculate, as they show here, what it is for 5 hours, we could just plug in a 5 for that h, right, into our function. We have 140 times 5 is 700. So we see it must be 700 miles after 5 hours. Okay, and they extended the table here to show that after 5 hours, the train in China goes 1,085 feet. Right. All right. Cool. All right, let's try another one here. And this one, again, you should be writing in your book. We're on page 312. Okay, so we're comparing two different things here. We have our table we see again. We have our equation here, right? The number of new movies a store receives can be represented by the function m equals 7w plus 2, where m represents the number of movies and w represents the number of weeks. Okay, so m is movies, w is weeks. The number of games the same store receives is shown in the table. Okay, so if we compare these two functions, compare the functions y-intercepts and rates of change. Well, if we look at this table here, we want to look at our y-intercepts and rates of change. So we see that with this first equation, we see our y-intercept is this 2. Remember, we represent the y-intercept with y equals mx plus b. Y equals mx plus b, right? And our m is our rate or our slope. Our b is our is that y-intercept. So we see that y-intercept for this one is 2. Whereas this one, there's no equation listed, but we can see by the rate of change that at 0 weeks, it would be 0 games, right? So this one has a y-intercept of 0. So our games has a y-intercept of 0. Our movies has a y-intercept of 2. Okay. We could even write out this function if that would be helpful for this one here. We could say, in this case, we're looking at games. So I'll say games equals free W, where W represents the weeks. Okay, and G represents the games. Okay, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. We see that function holds. And since there's nothing written there, it's really like a plus 0. So it has a y-intercept of 0 for this. Okay. All right. And so now we're looking at C here. How many new movies and games does the store have in week 6? All right. So we can look at this 2 ways. Again, if we want to solve this, we can look at our equation here and substitute that 6 in for that W there. We can do the same thing for this equation, or we can create a table. So let's go ahead and first do this table. Since it seems to be going up by 3s, let me just kind of write below it. Let's say week 4, we see it's going to be 12. Week 5 is going to be 15. And week 6. Week 6 is just right over this. 6, sorry. And week 6 we see is 18. Okay. So if we're going up by those 3s we have there, again, we can plug it into the equation as well. 3 times 6 being 18. So 18 games by week 6, okay? Whereas on this one, how many movies? We can just plug our 6 into that equation. So we're, again, going to substitute that W for 6. So really we have the equation M equals 7. And go ahead and please write this down as we do this. 7 times the quantity of 6 plus 2. Okay. Calculator is going to help us for this unit. Do that multiplication first. We get 7 times 6 being 42. If we add 2 to it, we would have, I'll go ahead and write this up, 2 steps. 42 plus 2 is 4. In other words, we have 44 movies in week 6. All right. So if we compare the two, 44 movies versus 18 games by week 6. All right. Great. So again, equations, tables, graphs, they're all just different ways of representing these functions. So we look at different ways to do that. Okay, let's see here. We're good. Again, this last example, we got one more here. Okay, So looking again, same thing here. If we are looking at a graph, they give us an equation here to compare. I'm not going to go over this in depth for time's sake. Just notice the y-intercept is right here at 60, right? The y-intercept right there is at 49. Okay, so if we're comparing those y-intercepts, we see this one has a higher y-intercept, so it's going to have a higher cost than that 49. All right. But again, if you need another example, you can read through that in your book. But we'll go through this one here together. All right. So Mandy and Sarah each have a membership to the gym. Mandy's membership is represented by the function y equals 3x plus 29, where x represents the hours with the trainer, and y represents the cost. The cost of Sarah's membership is shown in the graph. So we have Sarah over here, Mandy over here. All right, so let's look at our y-intercepts and our rates of change. So what is the y-intercept of, I'm going to go and write Sarah over here because I'm going to forget who's who. Sarah. Delete it, but I'll do that. Sarah. Okay. So we have Sarah here at our rate of our y-intercept. We see is at 0. That's where it intersects with the y-axis, right? It must be, it looks like 40, but if we look at the exact coordinate, we see it's actually 39. Okay. So there's an initial cost of 39 here for Sarah. So if we were to write an equation for that, we know that B is going to be our 39. Okay. What seems to be our rate of change? Well, we have 3 different points marked on here. So we'll have to, when we have those exact points, we'll have to use those points to figure out that rate of change. So let's go ahead and do these 2 here. So let's say if we're trying to find that rate of change, for Sarah, we have 75 minus 51, right? Remember, that's our rate of change. Change of y over change of x. So I'll put that over our change in x, 12 minus 4. And I'm just going to maybe double check that, but I think I got that. 24 over 8, right? Okay, is our rate of change. If we were to, if we were to simplify that, 24 divided by 8 is just 3. So we see this rate of change for Sarah is 3. Okay, so she has this initial cost of $39, and then it's $3 more per hour. Okay, this rate of change of 3. Okay, and if we look at Mandy over here, notice her initial cost is going to be $29. So that's really her B. And then our rate of change is also 3. So if we look at these 2 places here, compare y-intercepts and rates of change. So for Sarah, initial cost of $39. Mandy has an initial cost of $29 by RB. And they have the same rate of change, right? 3, right? So we could write this equation for Sarah here as y equals 3x and plus that cost of $39. Okay. So when we compare the 2, we see right off the bat, since they have the same rate of change, but a different initial cost, we know Mandy is going to be cheaper, right? Because they're going to keep going up at the same rate. But this one started at a higher point. Okay. So what will be the total cost for Mandy and Sarah if they each have 4 hours with the trainer? Well, we could plug 4 into the equation. This one's already done for us as 51, right? So really 3 times 4 being 12. 12 is 39 is 51. So yep. So Sarah we see is $51. Right? Sarah's 51. Okay. Whereas Mandy, what is Mandy? Well, let's plug into that equation. The 4 represents the x. So we're going to put 4 into that equation. So it's going to be y equals 3 times 4 plus. Okay. So if we add that up, we have 12 plus 29 equal that 41. So what will be the total cost for Mandy? $41. What's the total cost for Sarah? We see is $51. Okay. So all these are doing, again, it may seem complicated at first, but we're just comparing our tables, our graphs, our equations, our word problems, okay, and often seeing which one's kind of the better rate or how those two really compare, okay. All right, so I think that's all we need here for today. You should have some work to do with this that should be posted. So that's all. Let me know if you have any questions. Thank you.